Welcome to Exploring Computing. Today's video is Bits, Bytes, and Binary Part 1, or It's All About 0 and 1. Computers use the binary number system. So let's take a look at what binary numbers look like. We'll begin by comparing decimal numbers, which are the numbers we're used to binary numbers. Decimal numbers are based on the decimal number system, which is the number system that you are used to. In the decimal number system, there are 10 different digits, 0 through 9. All the numbers that you're used to seeing contain these 10 different digits. We also sometimes refer to this number system as base 10. In contrast, the computer uses a binary number system. In the binary number system, there are only two digits, 0 and 1. Here are some examples of the different types of numbers that you can make with the binary number system. We'll take a look in another video on exactly how these work and what they might mean. But for now, just realize that all numbers in the binary number system consist of only two digits, 0 and 1. And because of this, because there are only two digits, we sometimes refer to numbers using this number system as being base 2. What I want to look at next is why computers use the binary number system. If we were to open up the computer and look at computer memory, what we would discover is that computer memory actually consists of a whole bunch of different individual electronic switches. We can think of these electronic switches as being not that different than your light switch. And just as a light switch on the wall can either be on or off, our switches inside the computer can be on or off. When the switch is off, we think of that as representing the number 0, and when the switch is on, we think of that as representing a 1. So each of our switches corresponds to a single digit, and since these digits can only be 0 or 1, they're binary digits, and we shorten binary digit to bit. So when you hear somebody talking about a bit, what they're talking about is a 0 or a 1, or the memory inside the computer, which is being used to store that 0 or 1. Now, we can't really do a whole lot with a single bit, so we combine the bits together into groups, and the main grouping for bits is the set of 8 bits, which is referred to as a byte. The byte is the primary measure of computer storage. While I've been describing what happens inside the main computer memory, all computer data is ultimately stored as bits and bytes. So there are a variety of different mediums that we use to store digital information. And in each case, that digital media needs to be set up to store zeros and ones or bits and bytes. So an SSD drive, which is what's inside most of your laptops, stores information basically using electronic switches very similar to the ones we've described here. However, if you've got a hard disk, if you open up the hard disk, what you're going to discover is that there are individual sections on the disk itself that are magnetically polarized. And depending on the polarity, if the polarity is in one direction, it will be considered a 0. If the polarity is in the opposite direction, it will be considered a 1. If we take a close look at a CD, a DVD, or a Blu-ray, what we're going to discover is that the disk consists of a number of different sections, which are either what we refer to as pits or lands. Depending upon whether there's a pit in that section of the disk or a land in the section of the disk, ultimately what we're representing with these pits and lands is zeros and ones. So again, ultimately all information used by the computer is going to be storing these zeros and ones or these bits, and they'll be organized into groups of 8 called bytes. While our first video has been rather short, the other videos in this lecture are much longer. In the next video, we're going to take a look at how binary numbers actually work.